coal and petroleum. In our daily life, we need to fulfill our basic requirements. For this, we use various natural resources. These resources may be natural or man-made. We cannot live without air and water. Both air and water are natural resources. Things like clothes, house, furniture, computer, TV, fridge, etc. that we use are all man-made resources. Natural resources. The materials obtained from nature are called natural resources, like air, water, soil, wildlife, forest, coal, petroleum, etc. On the basis of their availability, various natural resources can be broadly divided into two categories: exhaustible and inexhaustible. Exhaustible natural resources. The natural resources which can be exhausted as a result of human consumption are called exhaustible natural resources, like coal, petroleum, water, forests, minerals, natural gas, etc. These resources are not renewed by rapid natural cycles. Inexhaustible natural resources. The natural resources which are not likely to be exhausted due to human activities and are present in unlimited quantities are called inexhaustible natural resources. For example, air, sunlight are inexhaustible resources. Natural resources such as fresh water, plants and animals are renewed by rapid natural cycles. Fossil fuels. Fossil fuels are naturally occurring carbon-containing materials which are burnt in air to give out heat energy. They can be defined as the materials of biological origin occurring within the Earth's crust which can be used as sources of energy. Fossil fuels are formed in nature by the decomposition of plants and animals which got buried under the earth due to biological changes that occurred millions of years ago. These are obtained from the earth either by digging or drilling holes into it. Fossil fuels are non-renewable energy resources because they take millions of years to form. Their reserves are being depleted much faster than their formation. Fossil fuels can be classified into three categories: solid fuels, coal; liquid fuels, petroleum, heavy oil; gaseous fuels, natural gas. Coal. Coal is a combustible black or dark brown rock consisting of carbonized plant matter. It is found deep under the surface of the earth from where it is obtained by digging. Formation of coal. Coal was formed from the dead remains of trees, ferns and other plants that lived 300 to 400 million years ago. Even swamps covered by seawater can also form coal. It is believed that dead plants were covered by rocks and soil and were decomposed by bacteria. Volcanic eruptions and earthquakes destroyed forests which also got buried under the surface of the earth and got covered with sand, clay and water. Due to high temperature and high pressure inside the earth and an absence of air, they got converted into coal. The slow chemical process of conversion of dead vegetation into coal is called carbonization. The volatile substances were driven off while the carbon content of the dead and decayed plant matter grew. Carbonization is a very slow process and may have taken thousands of years to convert decayed plant matter into coal. Coal is mainly carbon as plants contain carbon compounds, but the carbon content is different in different varieties of coal. The first step of coal formation results in a material called peat. It is an accumulation of partially decayed leaves, twigs, and branches. It contains a large quantity of moisture and a very low quantity of carbon. The second stage of coal formation is brown coal called lignite. It is composed of compressed woody matter that has lost most of its moisture. Therefore, the carbon content increases up to 70%. It is more solid than peat but still soft enough to crumble. The third stage of coal formation is bituminous coal. It is a dark, dense, brittle variety of coal that has lost almost all of its moisture and impurities. The carbon content in this variety is 80 to 85%, and it is therefore an efficient fuel. But when it burns, it produces ash and sulfur compounds which are pollutants. Anthracite is the final stage in the formation of coal. This is formed when bituminous coal remains in the earth for a long time and is subjected to extreme pressure. This is also called hard coal and contains over 90% carbon. Anthracite burns with very little smoke and up to a longer time than bituminous coal. Destructive distillation of coal. When coal is heated strongly to 1000 degrees Celsius in the absence of air, it produces various useful organic and inorganic products. These products are coke. The solid residue left behind after dry distillation of coal is known as coke. It is tough, porous, and black. It contains about 98% carbon and is used to manufacture steel and extract many metals from their ores. Coal tar. A thick black liquid with an unpleasant smell is called coal tar. It is a mixture of about 200 substances which are used in the manufacture of dyes, drugs, perfumes, explosives, paints, etc. The pitch derived from coal tar is used to construct roads. But these days, biomass, a petroleum product, is mainly used for making roads. Coal gas. The gas produced during processing of coal is a mixture of methane, carbon monoxide, and hydrogen. It is known as coal gas. It is a very good fuel and is used in many industrial units situated near the coal processing plants. Petroleum. Petroleum is a dark-colored, viscous, strong-smelling liquid. The name has been derived from petra, meaning rock, and oleum, meaning oil. Crude petroleum is a complex mixture of solid, liquid, and gaseous hydrocarbons mixed with water, salts, and other particles. It is a mixture of compounds. It is lighter than water and also insoluble in it. Petroleum occurs deep under the earth between the layers of impervious rocks. Since it is lighter than water, it occurs above the water layer. Natural gas occurs above petroleum oil under the rocks. Formation of petroleum. Petroleum is formed by the action of heat and pressure on the remains of marine organisms in the absence of air. The remains of marine animals which died millions of years ago settled at the bottom of the ocean and got covered with sand and rocks. The decomposed organic matter was buried deeper and deeper where high pressure and high temperature conditions liquefied it. The liquid then seeped down until it reached a bed of impervious or non-porous rocks and remained there like a lake of oil between the layers of rocks. Petroleum is obtained by drilling holes or oil wells into the earth's crust. When a well is drilled in the earth's crust, natural gas comes out first with a great pressure, and after some time, oil comes out itself due to the pressure of the gas. After the pressure subsides, the oil is pumped out of the wells and sent to refining units. In India, there are oil wells in Assam, Gujarat, off the shore of Mumbai, and in the deltas of Kaveri and Godavari. Refining of petroleum. The process of separating various constituents of fractions of petroleum by fractional distillation is called refining. Fractional distillation of crude petroleum oil is done by using a tall fractionating column in a petroleum refinery. Fractional distillation. The process of separating the constituents of a liquid mixture by heating it and then condensing separately the contents according to their different boiling points is known as fractional distillation. The constituents with different boiling points are termed as fractions. Crude petroleum oil is heated to about 400 degrees Celsius in a furnace, and the vapor thus formed are allowed to enter the bottom of the tall fractionating column through pipelines. The vapors of low boiling fractions rise up while the high boiling fractions are condensed at the lower side of the column. Fractional distillation continues till the crude oil is separated into 5. Various constituents of petroleum and their constituents of petroleum, temperature range, uses. Petroleum gas below 40 degrees Celsius, domestic fuel. Petroleum ether 400 degrees Celsius to 70 degrees Celsius. Solvent, dry cleaning. Kerosene 1700 C to 250 degrees Celsius. Fuel, illuminant. Diesel 2500 C to 350 degrees Celsius. Fuel, lubricating oil above 400 degrees Celsius. Lubrication. Paraffin wax above 400 degrees Celsius. Candles, Vaseline, grease. Pitch or tar above 400 degrees Celsius. Surfacing roads. Petroleum coke above 400 degrees Celsius. Fuel, electrodes. Natural gas. Natural gas, a fossil fuel, is often found in association with petroleum. It contains mainly methane and is used as domestic and industrial fuel. Compressed natural gas or CNG is also used as motor fuel as it is comparatively clean and does not cause pollution. It is supplied directly from the gas fields through pipelines. Such a network of pipelines exists in Vadodara and in some parts of Delhi. Natural gas is also used for the manufacture of number of chemicals and fertilizers. It decomposes into carbon and hydrogen on strong heating. Hydrogen is used in the production of ammonia, which is a raw material for nitrogen-containing fertilizers. Energy requirement. With the rising population and growth of cities and industries, our requirement for energy has increased manifold. Tractors and tube wells have become the backbone of modern agriculture. A large amount of energy is required in food processing industries. Domestic consumption is also increasing day by day. The transport sector too utilizes a good amount of energy. More than 75% of the world's energy requirements are met by fossil fuels, whereas petrol alone meets over 30% of the world's energy requirements. In India, coal meets about 65% of our energy requirements. A small percentage of energy is produced from crop residues and cattle dung, which has non-commercial utilization. Problems of overutilization of natural resources. Fossil fuels took millions of years to form, and our present rate of utilization of fossil fuels is much faster than the rate of their formation. It takes nature thousands of years to generate the amount of resources we utilize in a single day. If we continue to do so, very soon we will run out of them. Although there is no accurate parameter to estimate the amount of fuels available, it is said that if we continue to use them at the current rate, coal will last another 200 years and natural gas about 200 to 300 years. But there is always a possibility of increase in consumption with the growth in population and industrialization. As for petrol, specialists predict the shortage of fuel within 50 years. Some of the problems associated with overutilization of fossil fuels. The rate of utilization that depends on industrialization and growth of population is much faster than the rate of their formation. All countries of the world do not have equal reserves of fuel. They have to depend on other countries for their fuel requirements. For example, India is rich in coal reserves but does not have sufficient petroleum reserves. About 70% of the world's petroleum reserves are situated in the Middle East, Saudi Arabia, Kuwait, Iran and Iraq. Countries like USA, Canada, Siberia, China, Russia and Libya too have large oil reserves. The extraction, processing and utilization of fossil fuels pollute air, water, and soil. Judicious use of resources. We do not have enough energy resources to meet all our domestic and industrial requirement through fossil fuels. Therefore, we must not only use the available resources with utmost care, but must also not waste them. In addition, we should try to make use of renewable energy resources to meet our energy requirements. The advantage of using renewable energy resources is that they cause minimal pollution and provide energy too. Conservation of resources. The economic use of energy resources is called conservation of energy. Some important suggestions for energy conservation are: the electrical appliances used in homes, offices, schools, hospitals, and other establishments should be switched off when not in use. Use of solar cookers, solar heaters, and other appliances running on solar energy should be encouraged. Whenever and wherever possible, wind power through windmills should be used to generate electricity. Hydroelectric energy should be generated from water bodies with the help of dams and generators. Tidal energy should be conserved to drive generators. Energy should be generated from the biomass and be utilized in rural or semi-urban areas of the country. Petrol or diesel should be saved while driving for properly maintaining the vehicle, using correct type of tires, switching off the engine while waiting at the red light, and driving at a moderate and constant speed.